Okay, today we're going over 6.5 theorems about roots of polynomial equations. So the first thing that we're going to go over is how to find the rational roots. And what that means is if we're looking at a rational number, that is when a number can be written as a fraction or a over b. So rational just means a over b. Okay, and the roots, that's when we're talking about where your output is equal to 0. So if it's a rational root, then we're finding where this cubic will be crossing your x-axis. So to start, we're going to first find the possible rational roots. And I'm just going to write that as PRR, possible rational roots. And to find the possible rational roots, you're going to find all of the factors of the constant term divided by the factors of the leading coefficient. So we know that the constant term is the term that does not have a variable with it. So in this case, it's -3. And the leading coefficient is going to be the number in front of the variable with the highest degree, or the highest exponent. So in this case, your leading coefficient is a 1. So we're going to find the possible rational roots by finding the factors of -3, because that's the constant term, divided by the factors of 1, because that is your leading coefficient. So we'll list all of those. And when you're listing all of these, it's always going to have a positive and a negative for all of them. So plus or minus 1 is a factor of -3, and plus and minus 3. The factors of 1 are plus and minus 1. And then you would divide them. 1 divided by 1, plus or minus 1. 3 divided by 1 is plus or minus 3. So we have 4 different possible rational roots. So now what we're going to do is we're going to test these to see which one actually works. So when we test it, we're going to be using synthetic division. So again, we'll list our possible rational roots, which we just found to be plus or minus 1 and plus or minus 3. So I'm going to test one of the numbers to see which one actually works. So we can start with the 1. For these, there's only 4 to choose from, so it's not that hard to choose which one it will be. Even if you go through all 4 of them, that's only testing 4 numbers and it's not that long. If you get a lot of possible rational roots, what I would suggest is to put it into your graphing calculator as y equals this cubic and see where it crosses the x-axis, because that will be the root that actually works. If you don't have a graphing calculator, you can use the Desmos app, and it's a free app on your smartphone, or you can use it at home on your computer. So if you're watching this video, then you have access to Desmos. Okay, so we're gonna go ahead and test them. So let's just go ahead and pick 1, and then we'll test them. For synthetic division, we list all of the coefficients, 1, 1, -3, and -3. And we know that if there is a term that is missing, then we have to put a 0 in its place. Okay, so synthetic division, we bring down the first coefficient and then we multiply. 1 times 1 is 1. Then we add and then we repeat. 1 times 2 is 2. Add. We get a -1. multiply, and add. So this one did not work. That is not a rational root. X equals 1 is not a rational root of this cubic. So we'll test another one. Let's try -1. So we'll try -1 here, which is 1, 1, -3, and -3. We'll bring down the first coefficient, and then we will multiply and add, multiply, add, multiply, and add. And since we got a remainder of 0, that means that x equals -1 is our rational root for this cubic polynomial of 4 terms. If we wanted to go further and find all of the roots here, we would be able to do that. This number here is giving us the constant term. This is our linear term, meaning there's an x with it. And this is our quadratic term, or x squared. So, since we have x minus 1 as a root, we know that we always write it as x minus whatever the root is when we're writing in factored form. So this would be x plus 1 times what we just got right here, x squared minus 3. And we would set that equal to 0, just like this. We already know that when I set x plus 1 equal to 0, I get x equals -1. We had that one already. And now I can find the other roots here by taking x squared minus 3, setting that equal to 0, and solving for x. Make sure that when you take the square root, your answer is always a plus and a minus. So here are our other two answers. We have a positive square root of 3, and we have a negative square root of 3. So we knew we were going to get 3 answers because we had a degree of 3, so we have 3 answers. 2 answers here, and here's another one, which is a total of 3 answers. Okay, so let's try another. So if we are going to be looking at finding all of the possible roots, if we know that we have roots at 3 and 1 plus I, then the imaginary root theorem, it tells us that we will also have a root at the conjugate, which is 1 minus I. So if you have an imaginary root, you also have its conjugate. And the conjugate is just changing the middle sign. That goes for irrational roots as well. For example, if we have the square root, or 2 plus the square root of 7, then I also have 2 minus the square root of 7. This is by the irrational root theorem, and this is by the imaginary root theorem. So if we wanted to find the equation for this cubic polynomial, we would write this all out as y equals, I would have an x minus my roots, so x minus 3, and then I would have x minus 1 plus I, and I would have x minus 1 minus I. Okay, so now we're going to take this, which is our polynomial in factored form, and we're going to multiply it all out. So we'll take this and we'll multiply it. So we're going to go first, x times x is an x squared. Outer, this is a negative x times this binomial, 1 minus I. Inner, x times a negative is a negative x, 1 plus I. And our last, a negative times a negative is a positive, and then we have these two binomials, 1 plus I times 1 minus I. Okay, so then we can distribute in our negative x. And we'll just bring down our x minus 3 for now. And we get x squared minus x plus xi minus x minus xi. And then here we know that these are conjugates. So since they are conjugates, you do not have to FOIL the whole thing out. You only have to multiply the first and the last terms because the outer and the inner terms will always cancel out. So when I multiply this, I'm only going to multiply the first. 1 times 1 is 1. And the last terms. I times negative I is a negative I squared. So we also need to remember that I squared is equal to -1. Okay, so we'll continue here. So combining our like terms here, negative x minus x is a minus 2x. xi minus xi will cancel out. We know that I squared is a -1, so this is really a 1 minus a -1, which is a 1 plus 1, which is a 2. And now finally, we will just distribute in your x to every term. So we get y equals x cubed minus 2x squared plus 2x. And then distribute your -3 to every term in the trinomial. -3x squared plus 6x minus 6. And then we just combine our like terms. We have a -2x squared minus a 3x squared. So we have y equals an x cubed. There's no like terms, so x cubed. -2x squared minus 3x squared is a minus 5x squared. A 2x plus 6x is plus an 8x, and then minus 6. And this is writing the equation for when we are given the roots of a polynomial. And knowing that if we were just given 3 and 1 plus I, then I also know the conjugate of 1 minus I, which is by the imaginary root theorem.